Okay, I'm just going to wait 2 more minutes in case people are still joining. Can you all hear me fine? Am I audible? Yeah, okay, good. I can see that people seem to be joining, so I'll just wait 2 more minutes, okay? Okay, maybe let us start the class now. Uh, Let me just give me a second. Okay, yeah, maybe we can start the class now, and I'll just share my screen. Okay, so welcome everyone. This is We are almost at the end of this course, and as a result, also these problem solving sessions. So my name is Zenia. I am a PhD student and PMRF at IISc. I work primarily in astrophysics. And as you know, if you've been joining for the last several weeks, I've been taking these classes for you for how to solve problems relating to your course on Python programming. So this is meant for you guys to have a better idea of how to solve your assignment questions and also have yeah, basically it's we are solving questions which are related but not exactly our assignment questions, so you have a better idea of how to tackle them. Okay, so as always these sessions are recorded and the videos have been uploaded to YouTube, I've been uploading them to YouTube. So I'll just share my website here. I maintain all the links to everything. So this is my website. If you just go to my website, you can find that the course page is here, and then you also have the YouTube playlist where you have all the videos of all the classes that have been taken so far. After this session, this class will also be recorded and taken, and also you can find the slides of the sessions here. So in the slides, I also always include the programs that we discuss, the solutions to the questions we discuss as well. So this is how it's been going on. So yeah, just some important things in the beginning, and of course I have my email ID here. If you have any Python specific doubts, you can ask me. But as I always say, I'm not really in charge of these exam formalities and other things. So maybe if you have questions related to that, it will be better to direct them towards your Google discussion forum. Okay, just give me 1 second. So we can start the class now. So this class is going to be quite interesting as we have now reached almost the end of the class. You have already learned about these basic data types, libraries, and manipulations that you can do. And now we are moving to more specialized things. So one of the big advantages of Python, as I mentioned, I think in the very first class, is that this is an open source language. So anyone can contribute to Python and give their own libraries, their own code to Python. And as a result, you will find many specialized codes and specialized libraries in Python that people use for their specific purposes. Right? So now you can see that in this week's lectures, we looked at multiple things. So this is based on the week 9 lectures. So there is all these things about natural language processing, network X, programs on different kinds of problems like 6 degrees of separation, area calculation, etc. So I always show this slide in all of my classes, but this is important that you always choose meaningful variable and function names. You use comments and white space effectively, and so on. The goal is not just to learn coding, but to write effective code that you can actually share with other people and they can understand. So always make sure your code is, easy to understand and readable. I'm so sorry. Yeah. And try to always keep comments and other things active so that it's easy to refer to at a later date if needed. Okay. So natural language processing is the new thing that you learned this week. And this is something that's becoming more and more relevant as the days go on because now everything has somehow got AI in it, along with, the new phones, computers, even a Google search brings up all these AI results. So natural language processing is a subfield of AI that uses machine learning to enable computers to understand and communicate with human language. So you can see that NLP brings together all these different aspects of computer science and linguistics. And of course, we've already seen this in terms of your virtual assistants like Alexa and Siri. And this is becoming more and more prevalent with, large language models like ChatGPT, which are able to actually parse what you're saying and give you intelligent responses in real time, right? So these are the kinds of things that we have been discussing this week. Again, I'm not going into details because that's what your recorded lectures are for, but just wanted to refresh you on what the idea behind NLP is. Okay, so as usual, let's do some questions now. I'll first show the question. I think there is like 10, 15 of you in the chat. I'll be monitoring the chat on my phone. Please, all of you answer in the chat and we can, discuss after that. Okay. So first question is this. How can we identify which book is written by which author? Okay, someone says B. Any other answers in the chat? Okay, B. B. Okay. Okay. One person says D, others saying B so far. Any other answers? Okay, one more person says B. B. Okay. Okay, yeah, well, let's go to the answer. So the answer is actually B. So again, it's not a very exact science, but there is a way in which each author writes something, right? When you read a book by a particular author and then you write another book by the same author, even if the content is very different, they have their own style of writing. There are certain words that certain authors use more, use less, etc. So keeping that in mind, when we check the word length with previous books, like there may be multiple instances. Some people write very short and curt sentences. Some people write long sentences with lots of long words and stuff like that. So like that, you can actually fingerprint what book is written by what author. This is one of the ways in which you can do it. Of course, handwriting, number of pages, preface, these are all not anything to do particularly with a particular author, and that's why that's not the answer. Good. Okay, most of you got that right. Here's the next question. So, what is the key difference between lists and tuples in Python, both of which we have been discussing over the last few weeks, and when would you choose one over the other? Okay, B. Okay, I can see that most of you are saying B. Any other answers? Anyone else left to answer? Okay, if not, we can go to the answer. So the answer is B. Very good. So the main difference between lists and tuples is that lists are mutable, so you can always change. You can always have a list in a program. You can update it or delete elements from it, or add something to a list or replace an element of a list. All these manipulation you can do to a list. Whereas tuple is immutable. We saw many examples of this last week actually, and that means that tuple can be used whenever you have some data in a program that shouldn't be messed with or should be kept as it is, right? So this is what this is the basic difference between list and tuple. Okay, good. So next question is based on which network X, which is actually a Python library for looking at graphs and nodes and all these things. So one thing that before we go to the question, one thing that I wanted to tell, and I think I've told before, is that whenever you come across a new Python library, always try to look at its documentation. So you can just look it up like how I'm doing now. I'm just searching for the documentation, and you will always find that there's always a documentation page for any library you want. So this is for network X, but for NumPy, SciPy, whatever you want, it will be there. And this always has some, it'll have some proper information about the different, what it's used for, and also what are the different functions that are present in the graph, in the library. So this is important because in practical programming, we are not expected to remember all the things, right? Well, of course, in a course like this or for an exam, you may be asked to remember certain functions, but practically, when you are going to apply this to your problems or your field, you might not be remembering all the functions and all the specifics. So in that case, it's good that you can always know where to refer for understanding something about a function. Okay, and I think this is a good habit to have. Of course, you can go on Chat GPT or something, but you will only be, but don't just look for a particular function that you are using in that library. Try to have a broader view, and that is enabled if you look at the documentation page. Just a 2-minute scroll will give you a good idea of what can happen because they have a lot of examples also as well. So you can get an idea. Anyway, this is the question. So it's about this piece of program. Will this following piece of code always return true? Okay, someone says B, B, B. Okay. Okay, fine. We can go to the answer. So all of you said B. That's good. So it's not necessary that if you generate a random graph that it should necessarily give a connected graph as well. It can also give just a line, for example. So that is why it's not necessarily true. Okay, next question. What is the output of the following code? So again, this is based on your graphs and other things. Any answers in the chat? Okay, I can see one person saying D, another person says D. D. Okay, I think most people are saying D. Please, others also please answer. Yeah, the answer here is D. So here again, okay, sorry. So here again, you can see that we have 1, 2, 3, 4 as the nodes, and then the edges are 1, 2. Then 2, 1 is just the same edge again, so we don't have to worry about it unless it's a directed graph in which the order matters. But here, this is not a directed graph. This is something called undirected graph. So 1 to 2 and 2 to 1 are the same. Then we have 2 to 3, 3 to 4, 4 to 1, and we have this diagonal. So we get this rectangular shape that is obtained here. Okay, so that is why this is the correct answer. Okay, next question is what is the total degree of the given graph? Okay, someone says B, others B. Okay, D, B. Hmm. Okay, it seems like everyone, most of you are saying B. And the answer is actually B. So remember the degree of a given graph or the degree of a node is how many edges are starting from that node. If you want to find the total degree of a given graph, we have to sum up all the different degrees coming from all the different nodes in the graph. So for example, from here we have two edges, some from here we have two edges, from here we have two edges, and from here we have two edges. So altogether we have 8 as the degree because each node has a degree of 2. So if we sum up the degree 2 from all the 4 nodes, that's how we get the answer to be 8. Stop me at any point if any of this is confusing to you. Please let me know. But yeah, that's all. Okay, I'm just going to go to the next part now. Which of the following is always true for connected undirected graph with at least one edge? So this is a connected graph with at least one edge. Any answers in the chat? Okay, I can see that someone says C, someone says B, B, B. Okay. Okay, I can see that a lot of you are saying B. So the answer is actually B. Since this is a connected graph, that means that the entire thing is closed. There are no nodes that don't have any edges, that's not connected to, another node or anything like that. So there are no nodes which are left unconnected. That means every node is connected to at least two other nodes, right? One on this side and one on that side. So in that sense, we can think of it as always having an even number of nodes. So if there is at least one edge, then all of them should be connected to two. That's how you think about it. So every edge corresponds to two nodes, and then if you sum all of them up, it should be even. The Eulerian path and Hamiltonian cycle, you can look it up, but basically Eulerian path is a graph which goes through all the edges once, only once, and then Hamiltonian cycle is also something similar, but to do with the nodes instead of the edges. So you can look up the exact definition, but they are kind of strict definitions, and it's not always true for connected graphs, whereas the sum of all nodes is actually given, and you can actually look it up. There is some theorem which is associated with it. I forgot the name, but I had just seen it while preparing the questions. Okay, next question. What is the primary difference between using single quotes, double quotes, and triple quotes to create strings in Python? Okay, I can see that people are saying A to be the answer. Okay, so most of you are giving A. I think all of you have given A. That is the correct answer. Single and double quotes can only be used for single line strings, whereas triple quotes are used for multi-line strings. So if you want to write a string that goes through multiple lines, you have to use triple quotes in Python. And you can try this also in your program. We can try it right now. So if I have, let's see, Python 3. So that doesn't work, right? It tells me that I have to end it. Whereas if I give this as, it allows me to write something in the next line also. So that is the difference between a double quote in this case, or a single quote. Triple quote. Triple quote allows me to have a string which goes through multiple lines, and you can see that there's this new line character tab n, which is just, oh, sorry. So this is just a new line character which shows that there is a line break. So if I use triple quotes, I can have line breaks in my string as well. That's why. Okay, so we can go to the next question. This is the next question. How many nodes and edges does the following graph have? Okay, someone says A. A. Okay, good. So I think most of you have answered. The answer is actually A. So here you can see that let's count the nodes. So nodes will be the points that connect the 2 points. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 nodes. Whereas edges, if I count, there's 1, 2, 3, 4, 5. And you can see that actually these 2 points are also connected. So there's actually 6 edges and 5 nodes. This is of course not a complete graph because not all the points are connected. So it's not a connected graph, sorry, because all of the points are not connected. Okay. So next question is actually about a complete graph. So what is the degree of separation in a complete graph? Okay. Someone says D, someone says A, someone says D. D. Yeah, I will explain. First, let some people answer. So remember, this is not about a connected graph. This is actually about a complete graph. So maybe I can explain this because I can see that people are not answering. So let's first look at the difference between a complete graph and a connected graph. And then I think everything will become easy. So let's just see. So complete graph is connected to every edge is every node is connected to every other node. Okay. Whereas connected graph just means that you have this connection between all the nodes, right? So let's look at images that will help us understand. So here, for example, this is a complete graph because you can see that every point here it's based on houses. Every house is connected to every other house, for example. Here, this is a connected graph because no house is left unconnected, but it's not a complete graph because there are still, for example, there is no connection between this house and this house or this house and this house, right? So there are still nodes which are not connected to each other. So that is why there are two different kinds of graphs. This is a complete graph and this is a connected graph. So every complete graph is also going to be a connected graph, but not every connected graph has to be a complete graph. That is what we need to understand. So here you can see it again. All vertices connect to all other vertices. That is a complete graph. Whereas here no other edges connecting B and D. So this is not a complete graph. And of course, if you have an incomplete graph, this you've already seen in your lectures. Incomplete graph just means that there's some edge which is not fully connected. There's not a closed loop in the graph, right? So see, is thinking about all this now, can you think of what will be the answer to this question, which is the complete graph's degree of separation? Okay, so someone has given the answer of 1. Right, because degree of separation just means how many nodes I need to connect, right? So let's look at the exact definition of degree of separation. So when you said 6 degree of separation, it was like how many people you need to connect to reach from point A to point B, for example. So degree of separation in a graph is basically how many how yeah, the length of the shortest path which connects two nodes, right? So I just told you that in a complete graph that every node is connected to every other node. So because of that, the degree of separation in a complete graph is going to be 1 because all the nodes are connected to each other. Is this clear for everyone? Okay, good. So this is next question. What is the output of the following code? Okay, someone says B, C, B, B. Strings are immutable, so B. Okay, good. Good. So most of you have given the answer. String is actually much more like a tuple in the sense that you can't reassign any character. But of course, you can concatenate strings and you can increase the length of a string, but you cannot change it like this. So that is why this gives B. So you can also check it here. If you have any string, we saw this last week also, that strings are different from lists. They behave more like tuples because if I have a string, say A, B, C, D, and then I try to change A to, for example, capital S or something like that, it does not allow me. And of course, that's why strings are much more like tuples than lists. Okay, good, very good, everyone. Okay, let's go then to the programming part. So as usual, I'll give you like 10-15 minutes for each question, and then we can discuss the questions together. And now it's 6:40. So here's the first question. Oh, sorry. Here, this is the first question. We represent scores of batsmen across a sequence of matches in a two-level dictionary as follows. So you can see that there is a dictionary within a dictionary. That's why this is called a two-level dictionary. So you can see that in match 1, player 1 got some 57 points, player 2 got 38 points, match 2, player 3 got 9 points, player 1 got 42 points, and so on. Right? So in each match, there is some points that each of the players got. And of course, not all the players bat in all the matches, and so, you can see that player one has batted in match one and two, but not in match three. Player two is only batted in match two and three, one and three, and so on. So each match is identified by a string, and as is each player. The scores are all integers. The names associated with the matches are not fixed. That's here they are match one, match two, match three, nor are the names of the players. So that you can always have any number of names of players that you want, and a player need not have a score recorded in all matches. That's what I said. So for example, player one had a score recorded here, but not in the last match. So define a Python function called orange cap. So you know what an orange cap is, those of you who follow cricket, which reads a dictionary of this form and identifies the player with the highest total score. So your function should return a pair, which is player name comma top score, where player name is a string and the name of the player with the highest score, and top score is an integer, which is the total score. The input is such that there is never any ties for the highest total score, so don't worry about it. Okay. So why don't you try this question? I'll give you like 10 minutes. So this is based on dictionaries. So remember that in this Python course, that everything adds up. Okay. So like whatever you learned in lecture 1, you will be using in lecture 9 and so on. So always remember to keep that continuity going. So don't be like, oh, dictionary was not there in this class, so I don't know about it. You should always know about all the things that you're learning. And because you are always building on that, okay, there's a foundation. That is a foundation. Anyway, so you guys try out this question. I'll give you maybe, so it's 6:40 now. I'll give you till maybe 6:50, and then we can discuss the answer. Okay, so if you find the answer before that, please don't paste it in the chat immediately. Let's give everyone a chance to solve the question. You're reaching the end of your class, and I want you to have at least this time every week where you actually sit and try to do these programs. This is not very hard, so just need to know how to use the dictionaries properly. Okay. Okay, cool. So we'll discuss the answer at 6:50. Okay. So did anyone get the answer? Did any of you solve and get the answer to the question? Okay, good, good. So someone says done. Yeah, maybe you can share. Sorry. Yeah, you can share your code in the chat and then we can also look at, I can also discuss the solution. Okay, fine. Fine, you can share your answer later also. I'll maybe just discuss the answer now. Okay, fine. Sorry, wrong window. Let me just open the. Okay, okay, okay. So I can see that someone has given the solution. Nice, 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 nice. Okay, okay, fine, fine, fine. Good. So, so as you can see, the idea here is simple. The logic here is that we have two levels of dictionary that we need to go through, right? But finally, we have to collect all the same keys that are there in the nested dictionary. So there's an outer dictionary which is there for all the matches, and then the inner dictionary is for the individual player in the match, and then their number of runs and so on, right? So we have to go through all the matches, and then we have to now, what we have to do is we have to collect all the scores for all the players across all the matches, right? So, player one score in this match plus player one score in this match plus player one score in this match, for example. Like that, we have to do. Now, in this case, what we can do is we can now build a new dictionary which is just going to be player and score without caring about the matches. Because finally, we don't care about which player was maximum in which match, right? We want to find the player which is overall the highest in all the matches together. So that's why we want to actually put it as let's make another dictionary which only takes the player and the score into account and does not worry about the match. So this is going to be the logic that we are going to use when we are going to solve the problem. So let me just take the thing. Okay. So let's look at the solution week 9 program 1. So here you can see that we are going to define a function which is going to take it. So let's define a new output dictionary. So as I said, why do we need a new output dictionary? Because we want to have a dictionary which does not care about the matches and it only cares about the player and the score. Okay, so first of all, as I said, there is two levels to this. Sorry, two levels to this dictionary. This is a two-level dictionary. So the first level is the matches, and then within each match, we have another dictionary which describes the players and their scores. Right? So now if we just go to the where is the code? Huh, there's the code. So first we are going to go to, so this is basically match comma scores in match. So this is going to take all the dictionary items. Whenever you give d dot items, it gives the key and the value. So of course here the key is the match and the value is the scores in the match. So this is we are just at the first level now. The key is the match and the value is the second dictionary which gives the scores in the match. Now what I'm going to do is within that I'm going to again give, because this itself is a dictionary, I can just give that scores in match dot item, so that in that the key is the player's name and the value is the scores name. So again I'm just looking at, this is the level 1 of the dictionary, this is the level 2 of the dictionary. The point is that the values in this dictionary are themselves a dictionary. That's what is important here. Okay, so you can see that player underscore totals of player. So this is just me defining a new dictionary, right? So I want player totals to be my new output dictionary. So you can see that in my new output dictionary, whenever you define a dictionary like this, we've already seen here player will be the key and the total is going to be whatever you get. So whenever you give get like this, get is basically it gets the value from it just gets a value for the key that you're giving. So here I'm defining the key to be player. I'm getting the value to be whatever is this value from this previous dictionary. So you can see that player comma 0. So if in case there is no value for that, then I'm going to just assign it to 0. Otherwise, I'm going to add score to it. So that's the point. So you can see that this is what get does. So we can just see what get does in Python exactly. So yeah, basically it retrieves the value associated with a specified key, right? So here you can see that, uh, sorry, where is the thing? Yeah, so here you can see that whenever I give get of player, then it gets the score which is corresponding to that. If there is no such thing, this 0 is the default value. So that means that if that player is not playing in that game, we have to just put 0, right? So that is what this gives. And then we are adding on the score. So that is what this does. So this just adds up all the score. If the player is there, we are adding up the score. Otherwise, we don't do it. Okay? Because this just returns 0. So if not player totals, that means that basically if after doing all this you get an empty dictionary, that just means that your input dictionary was also empty. So we are just going to return that there is no top player and 0. Okay, now we have a new dictionary which contains all the names of the players and the scores added up from all the games that they have played. So now what we are going to do is we have to find the top player. So let's first just give some value for the top player as none and maximum score to be -1. And then we are just going to go through our new dictionary. And in our new dictionary, whenever we get a score which is greater than the maximum score, we just assign that to be the maximum score. So this is just going through each element and just finding out which is the maximum by just comparing with whatever is the maximum at one given point of time. And finally, you return the top player and the maximum score. So here I've given the same example that was given to you. And you can see that it just returns player 3 and 100 as the answer. So I think it's the same one: 57, 38, 9, 42, 41, and 63 and 91. So let's see. So 91 plus 9 is 100, right? So let's see. Player 1 is 57 plus 42, which is less than 100. It's 99. Player 2 is 38 plus 41, which is 79, which is also less than 100. And player 4 is just 63. So the maximum in this example is 100, which is given by player 3, 91 plus 9. So that is how this question is solved. Is this clear to everyone? Okay, great, fine. Okay, good. So now let's go to the next question. So the next question is this, okay? Sorry, wait. Let's go there. So positive integer m can be expressed as the sum of three squares if it is of the form of p plus q plus r, where p, q, and r are greater than or equal to 0, and p, q, and r are all perfect squares. Okay. For instance, so only certain integers can be expressed like this based on a particular example, a particular form. Okay, so for instance, 2 can be written as 0 plus 1 plus 1. Here 0, 1, and 1 are perfect squares, but 7 cannot be expressed as a sum of three squares. The first numbers that cannot be expressed as a sum of three squares are 7, 15, 23, and so on. So there is a particular theorem in mathematics. Ah, okay, okay. Yeah, that's fine. You don't have to identify, you don't have to get the correct answer. So someone in the chat has written something, so I'm just replying to that. Yeah, don't worry about the number that you got. The idea is more important is if your program works for the input that you gave. For the input you gave, got the correct answer, so it doesn't matter. Okay. Anyway, let's go back to this question. So the idea behind the first paragraph here, you can see that basically uh, most numbers actually can be written as a sum of three squares. Like 2 can be written as 0 plus 1 plus 1. If you have 3, 3 can be written as 1 plus 1 plus 1. 4 can be written as 2 plus 2 plus 0. 5 can be written as 2 plus 2 plus 1. 6 can be written as, sorry. not 2 plus 2. 4 plus 0 is 4, and so on. Okay, 5 can be written as 4 plus 1 plus 0, 6 can be written as 4 plus 1 plus 1. Like this. Basically, I have to write each number as the sum of three squares. But 7 cannot be written in this way. If you try to write 4 plus 1 plus 2, so 2 is not a square, so we can't write it in this way. So there is a particular condition that these numbers follow. It's called Legender's three square theorem. So you can go and check what this is. Once you see that, it will become clear what to do. So your idea is that first you go and see what this is, then write a Python function three squares that takes an integer m as a parameter and returns true if m can be expressed as the sum of three squares and false otherwise. If m is not positive, then your function should return false, because obviously negative numbers we cannot express as sum of three squares. Squares are always positive, so there's no way that we will get a negative number. So the idea is very simple. We just have to write a function called three squares, which takes an integer as a parameter, returns true if it can be expressed as sum of three squares, and false otherwise. Okay, that's all that you need to understand. Please put your answers in the chat. So, okay, don't put your answers in the chat. Sorry, I was just thinking of the thing. So, I'll do one thing. I'll give you till 7:10. Look up what this legendary three square theorem is, and then you can maybe try the program. Once you see what the theorem is, this actually becomes very easy. So, try searching this and then write a program. Let's discuss at 7:10. So, I'll give you 10 minutes. Don't put the answer before that. Let's everyone try, and then at 7:10 we can discuss the answer. Okay, good. Someone has got it. Um, any other people who got the answer? Any others who got the answer? Okay, I'll give 2 more minutes and then we can discuss the answer. Maybe in the meantime, the person who got it can share their answer. Okay, nice. Okay, good. So here the important thing that this person has used in this answer is this Legender's three square theorem. So as I said, to identify this is a mathematical result. So to identify how to do this question, we really need to read this. So maybe we can slowly go to the answer. So here, if I just search for, or I think I put it in the code. Yeah, so this is what Legend's three square theorem says. It says that positive integer n can be written as sum of three integer squares, that is n is x square plus y square plus z square, if and only if n is not of the form, sorry, this should be 4 to the power of a, 8b plus 7, where a and b are both non-negative integers. So it if so let's try to read that again. Positive integers n can be written as the sum of three squares if and only if n is not of the form. Okay, so that means that 7, 15, all these numbers which cannot be written as the sum of three squares, they are actually having this form. So simply we need to check whether our number has this form or not. If it has this form, that means we cannot write it as a sum of three squares. If it does not have this form, we can write it as the sum of three squares. So that's all the question is. So now it becomes easy. So first of all, we know that if m is less than 0, we have false because all squares are positive. So, we cannot have the square to be sum of three squares to be a negative number. So immediately if it is less than or equal to 0, we will be returning false. Apart from that, we are going to remove the factors of 4. So while m mod 4 is equal to 0, that means that while the number is still divisible by 4, I am just dividing it by 4. So I am just factorizing out the powers of 4 because you can see that this is there, right? 4 to the power of a. So that means that whatever is remaining, it should be of the form of 8b plus 7. If it is of this form, then it cannot be written as the sum of three squares. If it's not of this form, then it can be written as the sum of three squares. So if a number is having this form 8b plus 7, that simply means that the number mod 8 is equal to 7. So again, you can see that if m mod 8 is equal to 7, then it actually has this form. So it is returned false. It does not satisfy this condition. Whereas in the other case, it returns true. So we can think of it again in terms of the simplest number that they have given, which is 7. So in the case of 7, you can see that 7 is actually 4 to the power of 0 into 8 into 0 plus 7, right? So a and b are both 0 means we get 7. If I just keep a as 0 and b as 1, then I get 15, right? Because 4 to the power of 0 is still 1. 8 plus 7 is 15. And 15 is actually the next number in the list. And so on and so on. So it is a simple question, but you need to know what is that lemma. So now you know what is the actual theorem that leads to this thing. So we can check now with, for example, 7, you can see that the program returns false. If I, for example, enter some other number like 11, it returns true because 11 can be written as 9 plus 1 plus 1. So it can be written as the sum of three squares. And you will see that it cannot be written into this form of 4 to the power of a into 8b plus 7. So that is why this is the answer. Any doubts in this question? This is a simple question. You just, I didn't want to give you the answer. That's why I asked you to search and find out about this. But yeah, I hope you guys did that. Is this clear? Okay, good. Next question. Okay, next question. List of numbers is said to be a hill if it consists of a ascending sequence followed by a descending sequence, where each of the sequences is at least of length 2. Similarly, A list of numbers is said to be a valley if it consists of a descending sequence followed by an ascending sequence. You can assume that consecutive numbers in input sequence are always different from each other. So you have to write a Python function called hill value of L, which takes a list L of integers and returns true if it is a hill or a valley and false otherwise. So let's read that again. So in a list of numbers, if you have a sequence which has an ascending sequence and then a descending sequence, it should be at least of length 2. So that basically looks like a hill, right? Something going up and then going down. Similarly, a list of numbers is said to be a valley if it consists of a descending sequence followed by ascending sequence. So again, if you think of a valley, something going down then up, that is like a valley. So we have to put a list of numbers and we have to check, we have to put true if it contains a hill or a valley and false otherwise. So here are some examples to show how the function should work. So here, for example, you can see that 1, 2, 3, 5, 4. So again, you can imagine 1, 2, 3, that is a ascending sequence. Then 3, 1, 2, sorry, 1, 2, 3, 5, right? Until here, 1, 2, 3, 5, this is a ascending sequence. All the numbers are increasing. Then 5, 4 is a descending sequence. So there is a hill and a valley here. There is a hill here because we have this initially ascending sequence, then a descending sequence. And as they said, they should have at least two members in the each of the sequences. So 1, 2, 3, 5 has four members and 5, comma 4 has two members. So it is actually a ascending then descending sequence. Similarly, in this case, 1, 2, 3, 4, 5, this is just ascending, right? 1, 2, 3, 4, 5 is constantly increasing without coming down. So this is, does not have any hill or valley. In this case, 5, 4, 1, 2, 3, you can see that 5, 4, 1 is a descending sequence, 2, 3 is an 1, 2, 3 is an ascending sequence. So it has a valley in it. 5, 4, 1 is descending, 1, 2, 3 is ascending. Similarly, 5, 4, 3, 2, 1 is just a descending sequence. It does not have a valley or a hill in it, so it gives false. Is there any doubts in this question? Do you understand how this works? Does everyone understand how this question works? Okay, I'll give you maybe 10 minutes to solve this. If you have any doubts in the question, let me know. So it's 7:15, we can, you know, get 10 minutes and solve the question. Oh, okay. Here are the test cases. Someone had asked for the test cases. Yeah, please try this and then we can discuss the solution. I'll give you guys 2 more minutes and then we can discuss the solution. Okay, maybe we can discuss the solution. So again, here we have to identify whether a given list contains either a hill or a valley. So a hill is when you have an ascending sequence followed by a descending sequence, and a valley is when you have a descending sequence followed by an ascending sequence. And here you can see that each sequence should have at least two members for it to be counted as a hill or a valley. So if any of you have got the answer, you can share it. In the meantime, I'm just sharing the answer myself. So you can see that we have this program called hill or valley. We are taking the length of the thing. So if we take n less than 4, then we know that hill or valley requires at least 4 elements because we need 2 for each sequence, ascending and descending. So if the length of the list is less than 4, we automatically know that it does not have a hill or a valley. So this is the most basic check that you can have. After that, we are going to find the first change of direction. So you can see that I is equal to 0 while I is less than n minus 1. And if the next two numbers are the same, even though problem states they are different, we are just going to give this condition in case of anything. Then I plus is equal to 1. If I is equal to n minus 1, that means that all the elements are same. So we return false. Okay, so here we are just going through the list and checking if all the elements are different or not and all that. Then is ascending first is basically the point at which this is true. So we need to check for this case. So first we'll just set this to the case. So L of I less than or equal to L of I plus 1. So here this is getting the first case where the consecutive numbers are not the same, and then from there we are just checking if the next number is less than or greater than, right? So if it is less if the first number is less than the next number, that means it is ascending first and this will give true, otherwise this will give false. And we set a peak or trough index to -1. So now we are going to check for the peak or the trough. So now we are going to we have now identified the index where it is ascending, and then we are just if it is ascending first, then we have to look for a peak, right? So we are going to just check where until where the condition gets reversed. That is the element that is coming first is greater than the element which is coming next. In that case, the peak or trough index is j. So for example, in this sequence we get a peak at 1 2 3 5, right? So it keeps on increasing until 5, and 5 is the peak. So that's why this part will return 5, the index of 5 for us. Similarly, if this condition gave false, that means we are first getting a descending and then an ascending, which is a valley, right? Which is also giving going to contribute. So again, now if this is false, then we are looking for that means that it was a descending first index. So we are looking for when it becomes ascending. So basically, if it's an ascending first index, we are trying to see where it becomes descending, and if it's a descending first index, we are looking for when it is becoming ascending. Okay, and we are just identifying the peak or trough index, which is the maximum of the ascending or the descending sequence, uh, respectively. So if it doesn't change from -1, that means that no peak or trough is found, which means that it keeps on increasing. So for example, in this case, 1 2 3 4 5, there is no peak because it just keeps on increasing. That trend never reverses. So here we are actually trying to see the point where the trend reverses, and we don't find such a trend anywhere. So that's why this will just return false. So if you have a continuously increasing sequence or a continuously decreasing sequence, this is just going to return false to me. Okay, so then we are going to check the lengths of the sequences. We have to check whether each of the sequences should be at least 2, right? So if the peak or trough index minus I is less than 1, that means this is the length of the ascending sequence. It should be at least of length 2. So that gives false. If it is less than 1, that gives false. And then again, you're going to check the next sequence. So this is the first sequence. We have just checked until where is the peak. Now after the peak, we have to check. So 1 3 2 3 2 5 can work, right? Because 1 3 is a single sequence, 3 2 is another sequence. So I think that will work. So for example, in this case, 5 comma 4 is just two elements, but it still gives true. So it should be the correct way. Okay. Anyway. Okay, okay. You're saying it has. Okay, in that sense, you're saying. So then this condition should be 3, not 4, right? Because I was thinking, okay, ascending two elements, descending two elements. But you're right, the ascending and descending could be the same element. Like here, for example, it's 1 2 3 5 and then 5 comma 4. So it could still be three elements. Okay, good point. So, yeah, so if anyone hasn't seen the chat, so Akhil has just brought up that, you can have a hill or a valley with just three elements also. For example, you can have 1 comma 3 comma 2, which is like a ascending, then a descending. Then you have 3 comma 2 comma 5, which is like a descending, then an ascending. So, this is a good point. I didn't think about this. So this is why it's important for you guys to also solve. So let's change this to 3 because 1 maybe. Okay, good, good. I didn't think about that. Fine. So, where was I? So, yeah, we were discussing the program. So here, basically, we have now identified where the first sequence, and then we are going to, and then the peak or the trough of that index, and then from there we are going to check the second sequence, which is starting from the peak or the dip, and then from there going till the end of the list. So again, if it is ascending first, then the next element should be descending. Otherwise, if it is descending first, then the next element should be ascending, right? So we just check whether the trend is reversing or not. Here we were checking what is the point up to which the trend holds, and then we are checking now after the trend, is it actually descending or ascending properly? So this is the idea that we are giving. Okay. So you can see that the second sequence must also have a length of at least 2. That's what's checked here. So after all that, if all these conditions are met, then only it returns true. So you can see that in between, if any of these conditions are broken, you immediately return false. Okay. So that's what's given here. So now we can just try giving a sequence. Okay, wait. So it's again, it's a simple thing of like we have to keep track of everything, all the conditions. So first we have to identify whether a sequence is ascending or descending, and we identify up to what point it's ascending or descending. Then it becomes a point of, from that next point, if it is initially ascending, it should then continue to descend, or if it is initially descending, it should then continue to ascend. It should be the opposite way. So it can't be like that. So that is what we have to keep in mind. So let's try doing this now. So this is this was the first test case that was there, 1, 2, 3, 5, 4. So you can see that it gave true because it has a hill followed by, it has a hill, ascending sequence, then a descending sequence. Let's try this. Let's try the next one, which is 1, 2, 3, 4, 5, which is, just an increasing sequence. So that gives false. Now we can try 5, 4, 1, 2, 3. So in 5, 4, 1, 2, 3, we have true. And then if we give, what is it? 5, 4, 1, 2, 3. Then 5, let's give 5, 4, 3, 2, 1, which is a completely descending straight. That also gives false. Similarly, if I give like what your friend gave, like this, that is also true. And if I give 3, 5, I think, yeah, which is also true. So now it is checking correctly for all the cases. So again, here simply what we have done is we have just identified, we have put a condition for whether something is ascending first or not. Then based on this, we can find out, is it ascending first or is it descending first? And then based on that, we can find the peak or the trough that is there. After that, following this, we have to check if the trend is reversing or not. So that is also very important, whether the trend is reversing or not. Okay. So this is the program. Any doubts in this program? Okay. If not, let's go to the next program. So this is the next program. Good. Write a recursive function named power, so that accepts a square matrix A and a positive integer m as arguments and returns A to the m. So it's a simple program. Here what you have to do is, but important here is that it's not just a function, you have to write a recursive function. So I hope you all remember what recursion is. Can someone write in the chat what is recursion? Yes, exactly. So recursion is when you define a function, and in the definition of the function, it calls itself, right? So factorial is a very important or a very easy example of this. And remember, whenever you write a recursive function, you should always have a base case. Otherwise, remember that we will always have an infinite loop, right? So you should be careful whenever you write recursive functions to have the base case. So here we want to have a recursive function to find the power of a matrix. So remember that matrix multiplication is not just simple multiplication. There is some extra things that goes on. So if you want to refresh that, please search it, and then you can write a recursive function. Okay, I'll give you 10 minutes. We can discuss at 7:44, 45. Yeah, sure, you can use NumPy if you want. But make sure it's a recursive function. Have you guys solved the question? Okay, let me just discuss the answer so that we can end on time. If you guys have solved it, that's good. You can share your answers. Otherwise, I'll just discuss it now. It's a very simple question. This is simply getting the matrix input that we are getting. So you can see that matrix is, of course, a list of lists. That's how it's done in Python. And after that, we have this recursive matrix power function. So you can see that power of a comma m is given by, you know, for in this function of power, we are calling power itself. So this is why it's recursion in action. So remember that here we want to find a to the power of m, but of course, if you want to find a to the power of m, that's nothing but a into a power m minus 1, and then a into a minus m minus 2, and so on. So it kind of becomes like a recursive problem, and that's why recursion works here. Remember that if m is equal to 1, I have returned a, and this is very important because this is exactly my base case. If I don't include this, then my loop is just going to keep on going to m minus 1 indefinitely, and I'll just get a bad program. It will be an infinite loop. So that's why this base case, remember that whenever you have a matrix function, sorry, whenever you have a recursive function, you always need a base case. So in factorial, for example, you have to set 0 factorial is 1, and so on. So here we are just setting that a power a1 is just a itself. So that means that b, it will just keep on calculating this again and again until it reaches a power 1. And you can see that this is just the matrix multiplication. So a to the power of m of I comma j, you know that matrix multiplication, you do it like this. Ik and kj are multiplied element wise and then added together. So this is the matrix multiplication that is done here. I think some of you wanted to do with numpy also, it doesn't matter. Anyway, so this is taking input. Okay, actually, yeah. Yeah, this is just so that we can define a matrix to go here, and then this is for actually taking the input, and then we calculate the output. So let's enter maybe a 3 cross 3 matrix raised to the power of maybe 4. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. So apparently this is the answer. So let's see if this is correct. Okay. So let's give 3 cross 3, power is 4. Our matrix is 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So if I calculate 7, 5, 6, 0, 9, 2, 8, 8, this seems like what we got. Yeah. I think this is the same as what we got. So the answer is correct. If you want to really check, you can also check with the identity matrix. Because identity matrix to any power will just, oh, sorry. Yeah, you can check with the identity matrix, that is 1 0 0 0 1 0 0 0 1, because identity matrix to any power will give itself. So you can just do that as a check for your program also. So I have one more program here, but it's already 7:50, so maybe we can wind up. But I'll just show the problem statement and quickly discuss the answer. Uh, so here the last question is basically write a Python code to find the frequency of each word in a given string. So here again we'll be using dictionaries. So I'll just show you the solution quickly, and then we can and then I'll share these questions with you also. I'm not giving you time to solve because we're almost at the end of the class. So here you can see that the string is now split into a list of words, and then we are just looping for all the string values which are present in the sentence. So we are basically just yeah, here I have not used a dictionary, but you can also use a dictionary here. So for I in str, and then you're just going to add each of the words to str2, and you're going to append the unique words to str2. So the frequency of count, you can just use string.count. So count is a string function. So this is basically, so count is basically, it counts the number of non-overlapping occurrences of a specified substring within a given string. So here we are just using that to calculate it. You can also make a dictionary and you can have each the key to be each of the unique words and the value to be the number of times it appears and so on. So that is also applicable here. So just saying that you can always solve a problem in many ways. So this is basically how to do this question. So you're just using string.count. Here basically you use the lower case so that you don't have a basically you shouldn't consider this capital The and small the to be different words, right? Both are the. But if we don't use lower, then it will consider this to be a different word than this. So for eliminating that, whenever we put in the input, we put it as lower. So I can show you that in action. So here you can see, for example, frequency of the is 2. There is two the's in this sentence. The user tests the code. User is 1, tests is 1, code is 1. So you can even make it more sophisticated. You can see that here code and the exclamation point were considered. So you can put in an extra thing so that it doesn't consider any of the punctuation marks. So you can make like a string of like exclamation, question mark, quotation mark, full stop, and say comma, semicolon, and say that if the string has any of this, just remove that and only have the words. That also you can do. But point is that if I don't have this str dot lower, for example, then you can see that capital the is considered to be one word and small the is considered to be another word. We don't want that to happen. That's why this str dot, lower is very important. Okay. Is that fine? Any doubts in this question? Yeah, we can use is alpha check to avoid punctuations. Correct. That's also there. You can make a string of all the punctuation mark, or you can use is alpha, which then will give only the alpha thing. What if power is negative number for the matrix power problem? So I'm not sure how do you define the negative power of a matrix. Then you will have to take the inverse of the matrix and other things. See, matrix is not just like a number, right? When we take the inverse of a matrix, not every matrix has an inverse. There's these conditions that it should be non-singular and other things. So it became slightly different because A inverse and A, they have a relationship, but it's not so easy to find the inverse of a matrix like it is to find the inverse of a number, right? So in that case, it becomes slightly different. So it becomes more mathematical. You have to check for the determinant and other things. Got it. Okay, good. So that's why, because it can't just be treated like a recursion case, because not every matrix will have an inverse, so we can't just extrapolate it. That's why in the recursive case, you only consider the positive numbers. Okay, I think we can end. That was all I had. So as usual, I'll just share the link to my website to you guys in case you need it for the recordings and other things. And yeah, if there are no more questions, then we can end for today. Um, and I will see you at the same time next week. Or maybe I might have to change the class next week. I will let you know about that. But in any case, I will see you next week, either at the same time or maybe slightly different. I might have to change it. I will just let you know about the same. But in the meantime, have nice rest of the week. And yeah, see you guys soon. Okay. Bye, everyone. Bye.